All right, first question says, find the parametric equations for the hyperbola. Sorry you can't see that very well on your screen. But it says it has vertices at plus or minus 6, 0 and foci at plus or minus 8, 0. If you were going to sketch the picture of that, let's do that right here. They didn't ask us to graph, they're just going to ask us to write the equation. But sometimes it helps just to do a real quick little sketch. So you go this way 6, this way 6. So apparently the center has to be the midpoint between these two, so the center is going to be at the origin. The foci are at 8, 0 and at negative 8, 0. So you can tell your hyperbola is going to open like this. Okay, so that helped me to figure out which way it opened, okay? They asked me to write the parametric equations, but I think I'm going to write rectangular first, then move it to parametric. And so center's at the origin, and it opens horizontally. That means x squared comes first. So it's going to be x squared over something minus y squared over something equal to 1. Now, the things I know is I know that A must be 6, because that's the distance from the center to a vertex. C apparently is 8, because that's a distance from the center to a focus point. In order to write my equation, it is in a hyperbola, it always goes a squared, b squared, and I don't know what b squared is yet. But it does have a Pythagorean relationship, so you could say 6 squared plus b squared is equal to 8 squared, or b squared is going to be equal to 64 minus 36. Or, you know, if you just scoot this over to this side, and 14 minus 6 is 8, and 5 minus 3 is 2. Is that true? If you add these together, you get 64. 6 and 8 is 4. Yep, I think so. So b squared is 28. I really only care what exactly it comes out to be. I don't, it doesn't, it's going to, b is actually square root of 28, but I'm just writing the equation, and that's what goes in the equation. So a squared, 36, gets to go here, and b squared, which is 28, gets to go right here. Okay, so that's the rectangular equation, but they asked me to write parametric equations. If you're dealing with a hyperbola, easiest way I find to do it is to write secant squared minus tangent squared right on top. And then when you go to write your parametric equations, you have x equal 2 and y equal 2. This means that secant goes with x. That's a trig function that goes with x, so you write secant of t. Square root of 36 is 6. And the center was at the origin. I didn't really write that down, but center was at the origin, so you don't have to go plus 0 here. And then for y, tangent is the trig function, and square root of 28, that's what b is. So square root of 28, that's b. Does that simplify any? Well, square root of 28 could be called, since square root of 28 is 4 times 7, you could say it's actually 2 root 7. So we'll write 2 root 7. Sorry, that kind of came out squishy there. 2 root 7 tangent t. How about I rewrite it? Y is equal to 2 root 7 tangent of t. So, and there are your parametric equations, all done. The next section, they ask me to graph this, to draw the graph. They gave me the parametric equations, and they asked me to graph, okay? So I can tell from the parametric equations that the center of this is 1, negative 3. Notice these are not in parentheses, so you don't have to take the opposite sign. So the center of this is 1, negative 3. So if I was going to sketch the picture, I could already tell the center is at 1 and down 3. Because it always goes, remember when we did this one, secant was first. So if x goes with secant, that means the x is going to go first, which means it's going to be horizontal and open horizontally. So from my center, the distance A is going to be 3. So I go 3 units. I'm hoping you can see this. Let me double check. Yeah, okay. You're going to go 3 units to the right and 3 units to the left. So these are going to be your vertices, and the b value is 5, so you go 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. And this is how you sketch your little rectangle that the hyperbolas have. Like when you're sketching them, you draw your asymptotes. And then you go out here and out here. So center was the over 1 down 3. And remember this A right here is always the distance from the center to your vertex. And the 5 is kind of the endpoints of the conjugate axis. From there you go up 5 down 5. There we go. So you would match this equation to this picture. The next little set, all they ask us to do is to write parametric equations for these. Now, you can't tell initially, they didn't tell you what they are, and these are 3 different ones. When you look at this, because of the plus sign, I know it's something round, like a circle or an ellipse. Because the numbers under here are different, then I know that it's actually an ellipse, and it's a a vertically opening ellipse, because the biggest number is under y. The center is at -2, 1. Remember, when it's in parentheses, you take the opposite. And I can tell that A is 7 and B is 6. Okay? So when you write your parametric equations, you always go x equal 2 and y equal 2. We decided this is an ellipse. In all round things, you use cosine and cosine always goes with x, and sine always goes with y. So you can just look at your x, and the number below is 36. So what goes right next in front of the x is the 6. And then the x portion of the center is -2, so you write -2. And then we already wrote sine. You look at your y. The square root of 49 is 7, so that's what you put there. The y portion of your center is 1, so you go +1. So those are the parametric equations that are associated with this equation of a hyperbola. This is called the rectangular equation, and these are the parametric equations. All right, let's look at our next one. Because of the minus sign here, that throws a flag up that says this is going to be a hyperbola. It's going to open horizontally, and so every time I get an equation like this for a hyperbola, I always write on the top of it, secant squared minus tangent squared. And you could always remember, it's -10 because it gives you skin cancer. So that's how you know the negative always goes with the tangent, okay? And so you write x equal 2 and y equal 2. Then you just look at your x. It looks like secant goes with that. They always use a variable of t, which I left out when I wrote that, but secant of t, right below here, this will be a 3. The center of this is going to be 3, -1. So the x portion is +3. Then when you do y, you'd put tangent t, and then the square root of 4 is 2. The y portion of the center is -1. So those are your parametric equations for that hyperbola. You could tell it's a hyperbola because it was separated by minus sign. Lastly here, this is a circle, and it's got a center at 6, -2, and apparently a radius of 7. So we would write x equal 2, y equal 2. All round shapes like ellipses and circles that are kind of roundish, they use sine and cosine. So cosine always goes with x, sine always goes with y. And then the radius is, this is r squared is 49, so radius is 7, so that's what goes right in front. And the x portion of the center is 6, so you go +6. Y portion of the center is -2. And so those are our parametric equations for that circle. Oh, I'm sorry, you can't hardly see that. There we go. Sorry.